So I just created a new Aiken project.
Okay.
But I usually get it. Okay, I think the term is here. So there's no validators yet. I think we start from there. So let me create a validator. So let me paste it here. So let me copy back. Are you recording?
Yeah.
So I think I'm good to go now for now. Okay. Supposed to go to see the go back. And I'm in the right direction, I guess. So okay. So for this is the on-chain code.
Yes.
And we have two actions we are trying to perform: the mint and the burn action.
Okay.
And we are creating two validators for them, which is this and this. So I'm only confused about something. This my, why is this validator not working everything? Okay, I think because I made this. Yeah, it's coming out now. So yes, I'm good. So I just need a brief understanding on, a little bit brush up on the syntax. I understand what is trying to do, or maybe, okay, first of all, what is going on this on-chain code, so that I'll know before we move on, because I did a little bit of research on CIP 30, yes, and I was trying to look at those CIPs. I think I grabbed what they are trying to say. So they are all standards. Okay, you can go on.
All right. Go to the top.
The top. Okay, yeah, I'm at the top.
Right. You have got three libraries that you are going to use from Aiken.
Yeah.
One is the dictionary. And then the next one is the TX. There are three. There you have got output reference, script context, and transaction.
Yeah.
Right. These ones are part of the transaction. If you remember yesterday when I was talking about the transaction building steps.
Yeah.
For Cardano. But here you've got some libraries from Aiken that do that.
Yeah.
And number three, you've got value. Now that value, I don't know, what do you understand by that value?
I really don't have this good understanding of value pertaining to Cardano, because my own understanding of value, that value can be, is outside Cardano, not inside Cardano. I don't have an understanding of value is in Cardano yet. I haven't. I saw something close to it. I think it's a cyber something. It's close to cyber. I think so. Am I correct?
If you open that self-assessment test
Yeah. Oh.
on Oxygen,
Sorry. Self-assessment. Yes. I think the value is somewhere down. Okay, is that this ledger? Are you seeing my screen?
yes, I can see your screen.
Okay. There's other address, API, byte, context, credentials, crypto, interval, script,
And
slots,
number 12 is what?
value.
Right. I want to show you where you are going to understand this, because when you meet something, don't pass it until you understand it.
Okay.
If you go back to the Aiken code,
Okay.
yes, here, you are going to use those three: the dictionary, you are going to use the transaction,
Mm-hmm.
the TX,
Mm-hmm.
you are going to use the value. These are classes,
Yeah.
but you need to know what are their methods, because with a class, there is the class variables and the class methods. Even before you go really to the link I'm going to send you to see what these ones are,
Okay.
we can just track here on this code that is given, which is not a good way of doing it, just to see, okay, why are they importing the dick? See that part here.
Yeah.
Where is it used in the code?
I think the dictionary is to import all the built-in keywords and all that.
Where is it used in the code?
Okay.
You mustn't think, let's point. This is where it is used
Number.
for that dictionary.
I can't find where it's being used for now.
Then the next thing is we have got maybe Aiken standard library. You have got the link, or I must send you a link.
Okay, let me check if you've sent.
I've sent you a link on your WhatsApp.
Okay.
I can also send a link here.
I've seen it. I've seen it.
You've seen it?
Yes.
Yes, that part here. Now, can you click a for dictionary?
Oh.
What type of data structure is it? We know it from Java dictionary.
Yeah.
The key value collection. It's a form of a collection data structure, which has keys and values. And we need to know some other functions that it has.
Okay.
In this case, we have got what functions does it have? You can insert an element from computer science, you can insert an element, you can delete an element, you can use toList, or you can sort.
Yes.
You can filter. You see, there is filter. You can also toList. That is what. There is also, I think, a find. You can search elements in the collection using the method called find. There is something again called fold left. I think
Fold L.
yes, fold L for fold left.
Okay.
And then
fold R.
And fold right. Okay.
Fold right. Okay. Fold left and fold right.
Yes, fold left and fold right. Let's see what more we have. We've got from ascending list. That's another function from the dictionary. Dict from ascending list. From ascending list with. Then from list. See this dict. Let me call it dict or dictionary.
Yes.
And then we have got another method called get. You supply a key, you can collect a value.
Yeah.
Then there is another one which has key. This one is a Boolean method. It will check if the collection dictionary has got that particular key.
Oh.
This is the basic computer science data structures and what you call data structure methods and traversals.
Yes.
Right. If you are shaky on your foundation of computer science, you can just revisit data structures in Java or whatever language and look at different collections that are there. Simplest is a variable, array, dictionary, trees, whatever. Those are collection. For now, for me, I'm approaching it from a simple, simple to complex. This is a list. It's a container that is going to store things in a list format. Okay. Right. There are some things that I want to check here. You can check is empty. You can insert, and then how do you take out an element from a list? Does it have pop or it has got map? There we have, and map the values there.
Okay, to take out from a list.
Yes, how do you take out an element from a dictionary?
From a dictionary. For most data structure, they use push and pop.
Pop, yeah, but
Yes.
I don't see pop here. Do you have pop on
No,
this?
I don't think we have pop here.
Because remember, there is one thing you need to know. The Aiken data structure dictionary is tailored towards Cardano Smart Contract.
Okay.
It is, I doubt, it is not a general dictionary that we are used to. It is tailored. So, but still, it must have, for example, you want to take out the element on top of the list, element at the bottom of a list, or element anywhere in the list. You want to take it out. So, which are some of the methods it can use to take out elements from a list?
I think it can use delete.
Delete will remove, but it will not take it. We want to remove it. Yes, it will delete it. So, which means you first copy it somewhere and then you delete it. Delete it will remove it. Yeah. Okay, I think so.
Yes. Now, I'm checking it, and what I'm seeing here in the delete function, they inserted two values, two p and value. They now use delete to remove the first the first
yes, I see. They kept the key.
Yes, it's just the key that you use to reference it.
Awesome. Okay, we have understood this data structure that we are importing. Let's go to the next one. Go to your code, to the next one. Okay. Oh, before we go to the next one, in this code, which is very small, where is that collection used?
Okay, I'm seeing it now. I think it's used in the second validator to I think here there's a minted value. From minted value, then they are just trying to, I don't, this data, this is something is
you don't understand, isn't it?
Yeah, I don't understand the arrow function here for
that one is a pipe arrow, is a pipe angle, it's not actually an arrow.
Okay, is a type.
It is an operator. Ne?
Okay, iterator.
Yes, that operator, let me explain it. Because you see it a lot. You see it on line 20, 21, 22.
I see it a lot, and I'm always confused.
And then you see on 42, 43, 44.
Yes.
I'm going to explain it in very simple words, in a normal JavaScript.
Oh yeah, that's better. That's
you know when you are writing what do you call it, JavaScript.
Yeah.
You can chain functions.
Yes.
And how you chain functions, you use a dot.
Yes. Yes.
For example, you can use fetch, and then that fetch, you put a dot and get the results of fetch and chain another operation there.
Yes.
And then put another dot to chain another operation.
Yes, you can just using dot.
It's the same here. Instead of saying mint dot value tokens, here they put that. That is a specific Aiken chaining operator.
Okay.
So basically what they are saying there is if you look at number 19, mint from a mint is gonna first have the value from minted, that value from minted. When that value from minted, and then we go to the next time, we take that value and say tokens. We collect tokens after giving a policy ID to the function tokens. But you can't have the function tokens until you have got the value.
Yes.
Once you have the value, then you use the value to get the tokens. But for you to get the tokens, remember what I showed you yesterday. You need that policy ID, that long string.
Yeah. Yeah.
And then there you have got now the list of tokens, but they are in a mapping. A value is a mapping. It's not one digit. The normal way we know value is true. Value is 42. What is the value of the variable age? Is 92. Yes. No, the value here in Cardano, it's a mapping.
Is a map. Is a map.
It is a map of map of map. It is a mappings.
Okay, mappings.
Yes.
Okay.
You will see the example when we get into, when we look exactly what is value. But after that, you see the last chaining part is we've got those tokens in a value, then we just use now a dict dot to list. So that now your tokens are in a list format after minting them.
Yes.
All right. It's the same when you go down there. It's the same operator. Let's go to number 2 on top.
Number 2. Okay, yeah.
This one here, we've got output reference.
I've understood it.
You have understood it?
Yes.
Yeah. Good. Here comes Vanele. Vanele, you are welcome, ne?
Okay, let me.
Vanele, hello? Oh, he's still connected. Yeah, don't change. Augustine.
Okay.
Don't change where you are. Just keep where you are.
No problem.
Vanele, hello?
Yes, hello, sir.
Yes. You are welcome.
You're welcome.
Yeah. I've got Augustine here who is doing IK.
Okay.
Yes.
Okay.
And I want you to teach us. Okay. It's gonna be what we call it, a live session. Let me also encourage others who know IK to join.
Join, yes.
Then we all, what we call it, exploit together. You are going to understand deeper, Vanele, what you have been doing.
Yes.
Okay.
Yeah, can go ahead.
Right.
Yeah.
Now, let us carry on. You find us on the way. We are going to be moving. You are not going to lose anything.
No problem.
All right. Here we have got 3 transaction classes: the output reference, the script context, the transaction. Right. First, Vanele, what is that output reference and why do we need it here? What does it do? If you don't know, just say, no, I haven't found what it is. Then we explore it.
I haven't found it, I think.
You haven't found it. Okay.
Yeah, I haven't.
I want you to see it is part of the transaction. Augustine,
Yeah, I'm here.
open that documentation, click
Okay.
transaction.
Okay.
Let me also give Vanele the link.
We,
Vanele, you've got the link to the documentation standard library of Aiken.
For Aiken.
Yes.
Yes, yes.
You can be opening
That one.
also on your side.
I know, please share it. Please share it.
All right, I'm sharing it with your WhatsApp there.
Yeah.
okay, I've seen output to reference.
All right, there we go. Transaction now. What is the output reference?
Okay,
Read what it
I
says.
think there's a difference here. You know, the last time we came, we worked on the dict.
Dictionary, yeah.
Yes. So, and we are getting this one from. I don't want to make a mistake.
Okay, yes.
Okay, wait. The dictionary. Where is it again?
There it's on top. I can see it.
Okay. Yes, I can see it now.
Yeah.
So we got it from the modules. I
The
think there are
modules.
the modules and the types.
Yes.
Oh, sorry. I'm getting my.
Okay. You are bringing something very good. The
Yeah.
standard library of Aiken has got modules. Well, modules, you know, they are grouped codes, like classes,
Yeah. That's what I
like
just.
namespaces.
Yeah.
Yes, it's grouped code. So those are modules.
Yeah.
And
So
then
types.
you have got types. Now, types are data structures. I like what you have brought in here.
Yeah.
It is a data structure, a container of some sort. It will contain certain values. That is what you do. So I like what you have brought in. Do you see we have got output reference as a type?
Yes.
Click that. You've clicked that.
I've
Yeah?
clicked it already. Yeah.
And then what does it say there?
It say an output reference is a unique reference to an output on chain.
Okay. Now, remember what I showed you yesterday on the Explorer? The UTXOs.
Yeah.
You saw the input UTXOs.
Yeah.
I think that was the way we were yesterday, unless if
Yeah.
you
We saw the input here.
and then we saw the output UTXOs.
Yeah.
All right.
Let I bring it up.
Yes, you can open that what do you call it? You can click that, and then you go to the input. Remember, here you need CX Explorer.
I think Cardano scan, they are under.
Yeah, copy that and use that C Explorer. Where there's that snake, the red snake. Yes, search it there.
I need to use the prepod.
Yes. Remove collection. Click enter there. There we go.
Sorry, my network is kind of slow.
We don't need to be fast because sometimes when we are slow, we get it better.
Better.
I'm a slow learner because I'm old. All right, there we go to the
Next.
transaction now. Right. You can click one of these.
Okay, yeah. I'm supposed to click one of the.
Click the address.
I should think these are the inputs, these are the outputs. So
yes,
I should click on which of them? Okay.
anyone. Then click there where it says you see here it says transaction means
metadata.
because here this is showing the list of transactions, but it's not showing the list of UTXOs.
Oh yeah.
You need to know how to get the list of UTXOs from the explorers.
We did it yesterday, and I'm shocked I'm not getting the.
Just click one of the addresses there.
Oh.
Even if you click that one, and then you've got transactions UTXO at the end. On the tabs there, go to the end. Yeah, UTXO there. There we go. Right. Now I want to tell you the characteristics, the properties of a UTXO. Stop there.
Okay.
A UTXO has got a minimum of 3 things and around 4 parts. The first part is a hash that identifies that. You see that hash.
Yeah.
And then the second one is the index.
Okay.
Sometimes it is IDX. And then the third one is the value. Now, what did I say? I didn't say amount.
Yes,
what did I say? I said value. All right. I want you to see the first one, number 3, index 3. The next one is index 1. You will see this index 1, it has got the loveless.
Yeah.
And then after the loveless, there is that long string.
Yeah.
Yes. And then from there, it has the T out datum none. You see, here the inline datum, the datum it says none. It doesn't have a datum attached to it.
Yes.
Right. And then you see that long string.
Yes.
It is the assets.
Oh.
UTSO has got assets. Click that. It says it is 9. There is a number 9 there. If you saw that.
Yes, there's a number 9. Okay, it has 9 of the assets.
It has 9 of those. I think they are tokens. There is a plus sign there. We should be able to actually click and count those 9.
Yes, I've clicked it and this is it.
Okay, this part here.
Yeah.
Where are the 9? Count so that we see the 9. It must be under assets. Yes. Do you see on top there? It says asset. Then that is the asset ID. Then the data in the asset.
Okay, where?
All right. You are right there. Do you see we have got 9 of these Cardano Johannesburg tickets? We have 9 of them.
Yeah.
You see, this is the metadata of the asset. What type is it? This asset type, go to the red part which says NFT. Do you see this is a NFT asset type? Yeah. How many are here? It's 1 out of 1. So remember, this is the one that I sent to you. Yeah. If you check properly, you are going to see this on your NAMI pre-production network. All right. If you go to the sending, yes, that is the one. Perfect. So if we go back to value or to the UTXO, you are going to, I think I have made it very clear to you.
Yeah.
When you are programming in Cardano, you are basically creating a UTXO. And the UTXO, when you are creating it, it has got a hash, which is more like an ID, unique. It's unique, always different IDs. It has an index. That part is very important.
Okay.
Yes, it has an index. And that UTXO on the address, it is in a collection. An address is a collection of UTXO. That is why when you are picking a value for payments, value for sending somewhere, you do not pick one UTXO, because sometimes you don't know that one UTXO, it has got enough loveless.
Yeah.
These things like a loveless, which is the smallest unit,
Of
1 million loveless is going to give you one adder. So when I'm saying loveless, I'm talking about adder.
Yes.
Yes. And then you have got assets. Assets there that are on the UTXO, tokens, NFTs, which is fungible and non-fungible. Now, there is a third part, which is the datum.
Yeah.
Or a datum reference, which is probably an output reference that we did. Let me stop here.
Okay.
If you have no questions, I'm going to ask you questions. Difficult ones. But if you ask me questions, then I know, okay, you are getting it.
Okay, so now let me quickly, for my understanding, when we are building a UTXO, it contains three major sections, which are the hash, the index, and the value.
Let's call it value. Why? Because that value there, you've got the adder or loveless part, which is a coin.
Yes, yes.
And also it has got the tokens or the NFTs. We call those ones assets.
Yeah.
And then it has got some metadata concerning that particular payload. By payload, I'm talking to the NFTs, the tokens that are there.
Yeah.
So those are the components of a UTXO. And the one address is a collection of UTXOs.
Yeah.
Okay. Why are they called UTXO? Because they are unspent.
Yes.
The moment they are spent, this value that they are holding is no longer available on your wallet. They only appear on the Explorer. Before they were spent, they were on this wallet.
Yeah.
And they had this payload or value. Now, when they were spent, you can see which ones were produced and where the transfer went into. Once you master this, coding smart contract in Cardano then becomes easier.
Yeah, I'm getting it very, very well now. I just want to ask.
Yes.
So the value, the three of them are under the value. The Lovelace, which is one.
Yes.
And the
you see that part, they are separated by a plus.
Yes, they're separated by
a concatenation.
Yes.
You can see here that one that you have underlined has got one thing only. That one is only carrying loveless, which is 9161587. Only. It has no datum. It has no token. It has no NFT.
Yes.
Go down to the down at the bottom. There is that one. Yeah, that one there. I like that one. Stop there. You see that one, which has got value. Loveless. How much? 25946. Right. It's about 2.5 million, which is about 2.5 ADA.
Yes.
Okay. Now I want you to see there. There is that 980. It's a quantity for that particular asset, which could be a what? A list of tokens. 980 of them. And then you've got those 1. There's a 5 there. You see that 5? Yeah. And then these ones are assets. When I say asset, you must have two things in your mind. There is a name, there is quantity, and there is a type. It's an NFT, which means only one must exist, or it's a token where you can have series or many of different tokens.
Yeah.
Any question?
No.
Right.
Wait, I want to ask, sorry.
Yeah.
What is the meaning of the index?
The index, the two, let me tell you one thing. When I want to retrieve a token, remember it is sitting on a UTXO, but it happens that the UTXO is a collection on an address. Now that collection sitting on an address, the index and the hash identify where you get the token.
Oh, from the
You will see there you've got index 1111, 1, 2, 3, 4. There are 4 UTXOs with index 1.
Yeah.
But now what differentiates them is the hashes. The hashes are never the same.
Okay.
Yes. So what is the use for it? Well, as developers, I think it's used for indexing. Once you index, then probably when you are retrieving, it's going to be faster.
Yeah.
Yeah. That is how I can put it.
So it is just the index in the collection on that address.
This index is for indexing, like in a
yes.
You know, you sort according to index or ID, and then sometimes you can sort according to a compound primary key.
Yeah.
Yeah. I think its purpose here is for sorting, for quick search facilities.
Yeah.
There could be more explanation to this. The actual developers can correct us.
Yeah.
Right. What I want you to see with this one, which has a lot of assets, scroll up. This one, which is this one here. This one typically has got one UTXO, which has a lot of collections, different NFTs, different tokens. At the same time, they will always remember again. Each UTXO is going to always have one amount of ADA.
Yeah.
Or loveless. ADA and loveless is 1.
Yeah.
Actually, let's say loveless because it's the smallest unit. You'll be dealing mostly with loveless. On the blockchain, you'd hardly see ADA. ADA is a converted bigger value. It's divided by 1 million.
Yeah.
Yes. So on the exchanges, we are changing 100 ADA, 20 ADA here. But when we are cutting down the values that we are supplying, there is 100 million loveless.
Okay.
Just like the Bitcoin has got 18 zeros.
Yes.
Which is I don't know what is that. That is a billion or trillion. I don't know. Something like that. Okay. Any question here?
No, we are good.
From here now, let's say this UTXO is an output on a transaction.
Okay.
Because I want you to see one thing here. The transaction has got inputs.
And out.
It has got outputs, but those outputs now, it is sitting somewhere there on the Explorer. We want at some point in time to be able to collect it, or to go and read some metadata, or count how many NFTs it has, how many tokens, or validate that this particular wallet has got a particular NFT or a particular token. So there were two ways of adding metadata to the UTXOs. One was to actually enter the actual data as data onto the UTXO. That one was what was there before. So it meant each UTXO carried its own data. Yes. So now you can already see the problem of space. On chain, we don't have big space.
Yes.
So which means the datum you can put there is very little. You can't put big amounts of data there.
Okay.
That is number one limitation. The second limitation is for every UTXO going on chain, it is going with metadata, which is the datum. Then the cost is going to be more. The transaction fees are going to be higher. This is a common logic.
Yeah. Yeah.
Yes, because your transaction fees are determined by the size of your transaction.
Yeah.
The bigger, the more you pay. The smaller, the less you pay. So this again brings in the principle of smart contract coding. Make it as small as possible. Then you'll pay very little or small transaction fees.
Yeah.
Yeah. Right. Now they improved this. The current way they are doing it, they use a reference. One UTXO is going to have the metadata, but then there is going to be a reference. So whenever you are doing validation, you need to refer to the witness payload. But where is that witness payload? It's sitting on one UTXO. All what you need is a reference pointer.
Okay.
Then you use the reference. So now it means creating these UTXOs that are using reference pointers to a particular payload that was on chain. It becomes cheaper and faster. Don't need to carry that payload again. You only carry the address. And then with that address, then the validator is able to go and get that actual data that it needs for validation.
Yeah.
I think it has clarified things here.
Yes, I'm very clear now.
It's very clear. All right, let's go back to Aiken.
Okay.
Right. So here we've got output reference. Then we've got script context. But now, did we exhaust output reference as a module or as a type here in Aiken? Check. Let's check output reference. Output reference. All right. We had output reference, which is a type. But in this case, it is a unique reference to an output on chain, which is a transaction. That is what I need you to see here. You have got a transaction module. And this transaction module has got the following types. It's got the datum, which I think you now know.
Yeah.
It has got the input, which I have shown you. We have got the output, which you can check there. What I want you to see, can you go to click transaction or type there under search output reference? There is a search bar on top there. Type output reference. Right, click it there. Right. Can you click? Yeah, that part. All right. Let's go to the top. You are okay there. Click on it. Okay, on this output reference. I want you to see that this output reference here is part of a transaction module. Go to the top. Yes, this is what I wanted you to see.
Yeah.
It's a module that you are referencing on the other side of the code. And this module transaction has got the following types. It has got the datum, it has got the input, scroll down to the output, and the output reference is a type in the transaction module. Now, I think I'm clarifying things here.
Yes, yes.
Otherwise, even myself, I get confused. And then another type of the transaction is the redeemer.
Okay.
And then scroll down. Another type of the transaction here is the what?
Script content.
And then go down. What is the next one?
Script purpose.
Script purpose. Go down, down, down. Let's list all of them. Now we have got a transaction type of a transaction module.
Wow.
Yes. Right. Let's move up. You will see. I'm not discussing its constructors at the moment. Then we've got the transaction ID, which is a type of the transaction. It's logical. All transactions have got transaction IDs. And then we have got validity range. That one is very important because on blockchain, you have to calculate time before the deadline, after the deadline. So this validity range is an interval. This one we are going to use it a lot because our smart contracts are time-based. So that validity range, keep an eye on it. Go down now. If I were you, I'll take a pen and then for my studies, I'll study the transaction. I'll say TX module of Aiken. I'm going to tell you one advantage.
Yeah.
It is the same when you take another smart contract language on Cardano. If you go to Haskell, you are going to meet the same types. If you go to Helio, if you go to BlueTX, you will find those. Why? It's very clear. Why? Even if you go to different languages or smart contract development, you'll find this same type. I know maybe you might not know the answer. I'm just asking why to keep you thinking. But if you want to guess, that is good.
I think maybe it's because these are the requirements from the blockchain that it's needed for a transaction.
You have answered it correctly and in a layman's term. Thank you. Here, when you say the blockchain, we are talking about Cardano.
Yes, Cardano.
Here, remember, not the whole blockchain. We are talking about the smart contract that is running on Cardano, which we call Bluetooth core.
Yeah.
Bluetooth in general, when we say Bluetooth. Now, a Bluetooth primitive types is UPLC, untyped Bluetooth core. Those types are the ones that are created on different languages. If you know Bluetooth core built-in types, you will use any language. Okay, so we are not going deeper that way. All what I wanted you to see is to see the members of a transaction module, the types. We have seen the types. Down there, I see some functions. Let's see the functions. Right. Under the transaction, we are still under transaction. Right, we've got those functions, find datum, find input. So you can list all the files. The problem is if you don't know those functions, you won't know that you have to call them to get certain data. That is one thing why I want you to know them. Just like you have got those types, isn't it? They don't cater for everything that you need in developing a custom smart contract. That is why at some point in time, you have to create your own types. I think there is one which is called custom type, where you can customly build your own type.
Yeah.
Yes. So you can build your own type and use it. Then we have got the built-ins, we have got the standard ones that come like that. In a custom smart contract, it's unlikely everything is answered by these types that we have. Therefore, you will or might need to what do you call it? To custom build your own types.
Okay.
You get it now.
Yes, I guess.
Now let's go back to that code now, where we were on number 2 transaction. Now I think you can see script context, you can see transaction. All these three, well, they are going to be exported as TX. So the moment you say TX, it's more like a data structure that is carrying other data types or modules inside. Now, if you carry on with this code as it is, without understanding the script context, there is a lot of information that you are missing.
Wow.
So I am going to request you go to the standard library, the one you had before, click script context, read through it just for 2 minutes.
Okay. Content contains information about entire. Okay. Content limits with script. Okay, I think we should go on a little bit break so that I will get back. Like a 15 to 20 minutes break so that I will grab it very well. I'm trying to understand it fully. Are you there? Hello? Oh, I've understood. Okay.
Sorry, Augustine.
Yeah. I'm
You
understood.
just went to the other room. You can repeat what you were saying. Sorry.
Sorry. I was not understanding it, and I wanted to go on a break, but right now I can understand it very well. So essentially, the script context is trying to tell us the information about the entire transaction that contains the script. Like, okay, a transaction may contain other scripts, and to distinguish between multiple scripts, you need a script context to distinguish between multiple scripts in a transaction.
Yes.
I don't think is
Yes. Yes. Go on, because The script context is more than what you have said.
Okay, so they said it also contains a purpose, which indicates what the script is meant for. Or he said it also contains a purpose, which indicates which script or for what purpose of a transaction is being executed. Meaning this script, this particular script, what purpose is it meant for? This other one, what purpose is it meant for? I think
each script context will point to a different purpose. Now, the purposes are basically four.
okay.
It is mint. This script is for minting tokens, minting NFT.
Okay.
And spending. This one is for spending. And when it is spending, you are spending a UTXO. You know the term spending. For me, I say it is destroying.
Yes.
You are actually destroying that UTXO. Sometimes yeah. And for you to spend a UTXO, you need a output reference.
Yeah.
Right. Another purpose is for withdrawing staked funds. That's why it's called withdraw purpose. It's for withdrawing staked funds or staked ether.
Okay.
And then another one is for publishing certificates, digest certificates. So I've just given you 4 constructors. Any question about the 4 constructors?
So you gave me the 4 constructors you gave me for script context. You gave me one of it is for minting. The second one is for spending.
Yes.
The other one is for withdrawing.
Yes.
And the last one is
also delegating.
Okay, delegating, yes.
Actually, withdrawing, you are withdrawing from delegated. Other one is for what is that? It's for certificate. Let's read them correctly again. Mint, spend, withdraw, publish.
Okay, publish.
Yeah. If you go to Haskell now, on a Haskell Bluetooth coding, these constructors are what you see. They are there.
Okay.
That's an advantage.
Yeah,
okay.
I know Haskell has a very huge advantage over all the rest.
Right. This part, the constructors are of the script purpose. Okay. Now, that is one part. If you look at the script context, it has got 2, the transaction and also the what? The script purpose.
Yeah.
Now, the script purpose has got 4 constructors: mint, spend, withdraw.
Yeah.
And they publish. I normally draw a mind map like that because this thing tends to be deeper and complex as you go. So the TX, and then this time is the purpose, script purpose. And the purpose, we've got the mint, the spend, the publish. And then now we are going to look at the transaction. This one is very important for me. You know why? I spent a lot of time, almost months and months. I couldn't make a head or tail of how these guys, they wrote code. The code is working very fine. The code is fast, it's good. But I couldn't understand how all this blockchain money or values were being moved from one account to another.
Okay.
Until I had to do Bluetooth core modules. And these Bluetooth core modules,
yeah,
one of the modules is the transaction. You will see when I finish the transaction, you are gonna be more confused. Right. A move to the transaction module.
Okay, this transaction module.
Yes. And then let us look at the constructors.
I think this transaction is a module and is also a type.
Yes.
Okay, you said I should move to the transaction module.
Yes.
So I'm moving here.
Okay. Go down. Here you're under types. Go to the script, click script context. Yeah, you can click script context and go to transaction. Yes. Then go down. The purpose we've done this one.
Okay.
Right. Here, I want to show you this. You know, in Java, we've got what is called a struct.
Struct, yeah.
Yes, structs. So it is a struct, which is more like a data structure, like a class, but it doesn't have methods like a class. A class has got private and a public and whatever methods, yes. But a struct, it has got different types of types. It's a collection of different types. A struct. Yeah. So this has got the following, which are very important. The inputs. And I want you to list in your head. The inputs are a list, are a collection. That is why you see that template. It's a list of input types. That collection of input types, then you are going to ask yourself, what is that input? What is an input?
The input should be UTXOs.
Right. If you go to the actual input and type input, the constructors of input is a output reference and also output.
Yes.
So input is made out of output reference and the resolved value associated with the output.
Okay.
Right. Now, let's go back to the transaction.
I'm back.
We have got reference inputs. Now, this reference input is different from inputs, although the types you see here is just a collection of inputs. Reference inputs here now is another list of inputs, but these are reference inputs.
Okay.
It is a list. That is number 2. Number 3 again is a list of outputs.
Okay.
So you can see this transaction object. It's a huge object.
Very huge.
It's one object with a lot of collections inside. Collections of inputs, collections of reference inputs, collections of outputs. And then it has got value. Now, that is what I want you to look at. Value is a capital letter here.
Yeah.
I want you to check what is value according to Aiken.
Okay. I'm not seeing it here.
You can type on the, what you call it. Let me see where you find value here.
Okay, I've seen it.
You have seen it? You
Yes.
found it.
A VAT is a multi-asset output, contains tokens indexed by policy ID and asset name.
Yeah. Wait there. I want you to underline the word multi-asset.
Okay.
And you must see this value is a type. And this value type is a big object. That is one thing I made a mistake about. I always thought value was referring to eta. I thought when I write my function and I said value, I would assign 200 eta, 300 eta to it. No, it's not like that. Eta is part of value. There are NFTs, there are tokens. There is even what? Metadata. That too. Now, I want you see here they've said there's policy ID and there is asset name. What is an asset name?
An asset name is a group of maybe something like, I'm confusing it between two things now. I'm saying okay. I think it has to be either a fungible token or a non-fungible token or either. Maybe one of those three.
Click that asset name.
Okay.
What does it say?
It says a type alias for asset name, which are free form byte arrays between 0 to 32 bytes.
It's a type alias. It's another name.
Yes.
Okay. Or asset name. And then it says the alias is asset name is equal to byte array.
Yes, which is like a string.
Yeah, a string. So the type of a string, which is the lower level,
Yeah.
in Bluetooth core is byte string.
Okay.
And this untyped Bluetooth core, at the lower level, everything is byte string.
Wow.
Yes. The redeemer at the lowest level, it is a byte string. The datum at the lowest level, it is untyped. That is why any other language can compile to Bluetooth core. All right, let's get back to the transaction.
Okay.
The transaction has got a value. That value is the fee for the transaction, remember?
Yeah.
And then it has got mint, which is a minted value. Here, how many of these tokens have been minted? And we've got certificates. Here, a list of certificates. You need to know what is a certificate here and what is its purpose. It's a security tool. For example, if I'm delegating, then I delegate to a stake pool. But how do I know that stake pool is authentic? It must have a certificate.
Okay.
And then we have got withdrawals. Now here comes again that data structure dict. Now it is a collection of what we call tuples. A tuple is like, for example, it is a collection of a stake credential int. That's a tuple.
Yeah.
They use another name I've forgotten. Where you've got a data type that has got different types in it. As opposed to array. An array, all elements belong to the same type. You can't have one array where the first element is an integer, the second one is a string, not an array. But
it's for byte.
Is like that.
Okay.
So for me, I can say maybe a tuple, it is a data structure, a type that contains elements of different type.
Okay.
An array It's of the same type.
Yes.
Okay. All right. Now, I want to ask you one question.
Okay.
Why is it inputs, it's a list? Reference inputs, it's a list. But when we come to withdrawals, it's a dictionary, because those two are collections.
Yes.
How are they different?
Okay, first of all, I have to think a bit now.
How are they different? Why are they using this differently? Why didn't they use all of them, dictionaries?
I think maybe the a list stores the same type of data, but a dictionary can store different type of data, and there are different type of things you can withdraw. I think.
So you're actually saying a list is an array?
It's not necessarily an array, but
not an array.
A list is not an array. It's just. Do we even have an array in this Aiken? Because I've not
Array is a, yeah, you can use array there. But on their types, we've got a list. You can have an array of integers.
Wow. Okay. I don't know why. I don't know. I don't think I know why they use a dictionary.
The properties are different.
Okay.
The methods are different. If you check list, has got methods like any, add, concat, count. Okay, count is there, delete is there. Difference, now it has difference, list difference. List drop. That one is delete.
Yeah.
This one is drop. Drop while. It's a collection. I think a list is a lighter, bigger container. A dictionary is a bigger
container. Yeah.
Yeah, it's a bigger, more complex
container
compared to a list. In terms of memory, I think a list takes less memory.
More than dictionary.
And it is not robust from what I know from other languages. Other languages, we've got an array, we've got lists, we've got trees, we've got dictionaries. We know from my side, I know a dictionary specifically is a key value. No, this thing defines a dictionary. It's a key value. In a dictionary, it's like a database, a light database. What is sent to a dictionary? It has to be two parts, a key and a value. In a list, you can have a list of 7 things without a key. There is no key in a list. I think it's becoming more clear. This is a basic computer science knowledge foundation.
Yes.
Of data structures. In a list, of course, you can have a list with inside the list, you have an array. The next part of a list could be something else. And then another part could be something else. But it is not a key value. You can have one item elements in a list. But in a dictionary, each item is a key value. So which means a dictionary is going to have some things like indexing, filtering, sorting. Even a list will have sorting. But I think a dictionary is going to find things quicker using the keys.
Yeah.
Those are basic computer science data structures. All right. So that is why you'll see the first 3, they use the collection list. And then when it came to certificates, when it came to withdrawals now, then there they used a dictionary, stake credentials, and int. And then we have got validity range. That one is exactly what I told you.
Yeah.
This validity range, in a simple way to tell a person who is starting, is it is time, period, on blockchain. The way we measure period on blockchain is different from the way we measure period here. Our period here can boil down to seconds, from one end to the other, seconds. But what about on blockchain? On blockchain, because according to the blocks, each block in Cardano is minted in what, 2 seconds, 3 seconds? Is it 1 second, one block? And then now, how many blocks is it going to take for this smart contract to allow people to withdraw money? A validity range is very important.
Okay.
Yeah. And then we've got extra signatories. There you see they used a list, and in that list, they used another template, hash. Here is another collection called the hash. You can see it is a template that takes Lake 2B 224. What is that? That is an encryptor. That is a, what you call encrypting algorithm. Blake 2B 224. You know, that is a tool for encrypting.
Okay.
And then on the other hand, you've got verification.
Yeah.
Yes. All right. We will deal with keys later on.
No problem.
And then we have got the dictionary redeemers. So you can see the redeemers. They are stored on a transaction, on a collection called it, which is dictionary.
Yes.
And the redeemers, script purpose, redeemer. It's a collection, script purpose, redeemer. Remember the script. What is the script purpose?
The script purpose. The script purpose is to know the particular script meant for that to know the particular purpose on a transaction, because the transaction has many scripts.
Yes. And then we've got the datum, the collection of datums.
Yes.
Okay. And then every transaction must have a transaction ID, which is a hash of the transaction items. I think it's the transaction that is coming here must be uniquely identified. And the transaction, once you have a transaction hash, you go to the Explorer, you'll be able to pull out the transaction. And in the transaction, you'll be able to see the inputs, the outputs. And then inside, you'll be able to see the assets, the tokens, the NFTs.
Yeah.
I spent a lot of time on this.
Yeah.
Definitely, we are going to come back to this.
They're going to come back, yes.
Yes, you are going to see. Now, after looking at this data structure, and you can see how complex it is. It's a very complex data structure, because it is a data structure basically composed of everything. That is a collection. So it's a collection. It has got collections and collections and collections and collections inside.
Yeah.
Now, let's pause a moment and think. So now, if I want to create a transaction, so does it mean I need all of this? You need some of this. You need inputs, not one input, several inputs. And you will produce several outputs and still store all these list of inputs and list of outputs on an object transaction with a transaction ID.
Yeah.
If you looked at that UTXO that I showed you on the Explorer, You saw transaction hash ID. You saw inputs and then the UTXOs. You saw the outputs. And you saw the NFTs. And if you looked at each of those, they are in collection. You click a star, it opens. Then you see another collection in another collection. This is the data structure for like a class, the design. Yeah, this is the design for that.
Okay.
Now, the transaction ID, how is it created? They use hash. It's a hash, I told you. And then that hash, it is a hash using this hashing Blake 2B underscore 256. And then on the other side, you hash a transaction. And this transaction you are hashing, it is all those things that we have seen all together, put together, then you hash. From here, it is going to be a little bit easy. You will find it a little bit clearer when we go to the code.
We can find it. I think we should come back before we go to the code. Let's just go and break so that I can answer some calls. Then I'll come back.
All right.
Maybe we'll come back in the next 30 minutes. I think it's better.
All right. I'm going to stop this one. When we come back, we are going to record another session.
No problem. No problem.
Let's take a break for 30 minutes or so. Let's say 3 o'clock.
Yes.